Hi everyone, we will discuss about nonlinear oscillation. Example, consider a particle of mass suspended between two identical springs. Shows that the system is nonlinear. Find the steady state solution for a drift. This figure, you will see, makikita natin na may dalawang strings. So, pag hinila natin tong strings punta dito, so ito yung kalalabasan ng ating figure na ating magagawa. So pag hinila natin, may force na, so ito yung force na paghila natin. F equals negative K S minus L. This is the force. Sa paghila natin, ito yung force na makukuha natin. So, may dalawa tayong springs dito. Ito yung upper tsaka yung lower spring. So, dito sa upper ay kukunin natin yung horizontal spring dito. So, sa upper, ito yung sa F upper. So, equals equation natin negative. So, yung equation natin, ito yung equation ng horizontal. So, f of x up, so upper equals f sine of theta. So, yung F natin, yung force ng paghila natin, so, equals negative K S minus L sine theta. So, sine theta. Ito yung F of upper natin. So, yung lower na naman, F of x lower equals, ito pa rin yung equation na gagamitin natin sa horizontal to na equation, sine theta equals negative K S, so minus L sine theta. So, ito yung graph natin. String yan. Tapos ito yung theta tsaka x. Ito yung upper kuha natin, upper string. So, yung force dito, kasi pa horizontal, f of x natin. Ito yung f of x natin. So, ang lower naman, parehas lang yung lower natin. Yung lower natin, ito yan. Parehas lang sila, kaya para makuha natin yung horizontal, force, i-add natin itong F upper plus F lower. So, F total equals F upper plus F lower equals, so pag in-add natin yan, makukuha natin F equals negative K times S minus L times sine theta plus negative K times S minus L sine theta. So, pag inad natin yung dalawa, kuha natin ng F equals negative 2k S minus L sine theta. So, ito yung horizontal force natin. So, we have here the solution. If both springs are in their unextended conditions, there is no tension and there is no potential energy in either springs. When the particle is displaced from equilibrium, each spring exerts a force negative k times S minus L on the particle. K is the constant of each spring. The horizontal force on the particle is F equals negative k times S minus L times sine theta plus negative k times S minus L sine theta. So if you solve this, you will get the horizontal force here. F equals negative 2k times S minus L sine theta. So this is our horizontal force, net horizontal force. Now we have S equals square root of L squared plus X. So this is the graph of X equals square root of L squared plus XL. We have here. So sine theta is equals to X over S equals X over square root of L squared plus X squared. Hence, F equals negative 2kx over square root of L squared plus X squared times square root of L squared plus X squared minus L is equals to negative 2kx times 1 minus 1 over square root of 1 plus X over L squared. So if we consider X over L to be a small quantity and expand the radical, we find F equals negative KL times X over L cube times 1 minus 3 over 4 times X over L cube. So plus. So if we neglect all terms except the leading term, we have approximate F of X equals negative k over L squared times X cubed. So therefore, even if the amplitude of the motion is sufficient restricted so that X over L is a small quantity, the force is still proportional to X cubed. The system is therefore intrinsically non-linear. However, if it had been necessary to stretch each spring a distance d to attach it into the mass when at the equilibrium position, then we would find for the force F of X equals negative 2 times kd over L X minus k times d L minus d over L cube times X cube. And a linear term is introduced. For oscillation with a small amplitude, the motion is approximately simple harmonic. E prime equals negative p times L minus d over L cube is less than 0. So thus the system is hard. So if we have a driving force F sub O cos omega t, the equation motion for the stretch spring becomes m double m of mx double dot equals negative 2 kd over L times x minus k times L minus d over L cube times x cube plus F sub O cos omega t. So let E equals E negative E prime over M. E equals 2 kd over ml, and G is equals to F sub O M. So then we have here x double dot equals negative ax plus e x cube plus g cos omega t. Is a difficult differential equation to solve. We can find the important characteristics of the solution by a method of successive approximations, perturbation techniques. First, try a solution x sub 1 equals capital A cos omega t, and insert x sub 1 into the right hand side of the equation, which becomes x double dot sub 2 equals negative A capital A cos omega t plus E capital A cube cos cube omega t plus G cos omega t, where the solution of the equation is x equals x sub 2. This equation can be solved for x sub 2 using the identity cos cube omega t equals 3 over 4 cos omega t plus 1 over 4 cos 3 omega t. Using this equation gives us x double dot squared equals negative A capital A minus 3 over 4 E capital A cube minus G cos omega t plus 1 over 4 E capital E cube cos 3 omega t. So by integrating twice, which integration constant set equal to 0 gives x sub 2 equals 1 over omega squared times A plus A capital A equals 3 over 4 E capital A cube minus G cos omega t minus E A capital A cube over 36 omega squared cos 3 omega t. So this is our answer. Another example, if each of the spring must be stretched a distance d to attach the particle and the equilibrium position, in its equilibrium position, the particle is subject to two equal and opposite directed forces of magnitude kd, then shows that the potential in which the particle moves is approximately. So ito yung kalalabasan ng ating example ngayon. Ito yung answer niya. So, dapat ito yung makuha natin. U of x equals key d over L times x squared plus key times L minus d over 4 over L cube 4 L cube times x to the power 4. Half of our example, makikita nyo yan dyan sa A, the unexpected length of each spring is L over O. So sa A, makikita yan sa A. In order to attach the mast, M spring must be stretched the distance as indicated in B. So na-stretch yan dyan sa B. And sa C naman ay when the mass is moved a distance of x. So yung mass na move sa distance ng x yung pinapakita sa C. So the force acting on the mass neglecting gravity is F equals negative 2k times S minus L sub O times sine theta, where S equals square root of L squared plus x squared and sine theta equals x over square root of L squared plus x squared. So then we get this equation F of x equals negative 2k x over square root of L squared plus x squared times square root of L squared plus x squared minus L sub O equals 2kx over negative 2kx over square root of L squared plus x squared times square root of L squared plus x squared minus L minus D equals negative 2k x times 1 minus 1 over D ay 1 minus D over square root of L squared plus x squared equals 2kx times 1 minus L minus D over L times 1 plus x squared over L squared negative 1/2. Expanding the radical in powers of 2 squared over L squared and retaining only the first two terms, we have f of x equals negative 2k x times 1 over 1 minus L minus D over L times 1 minus 1/2 x squared over L squared equals negative 2k x times negative 1 times negative 1 V over L plus 1/2 L minus D over L x squared over L equals negative 2kd over L x minus k L minus D over L cube times x cube. So the potential is given by U of x equals negative, so it's given by negative integral of f of x dx, so that we get our final answer. So as you see here, our final answer is U u of x equals key d over L x cubed plus key L minus d over 4L cubed x to the power of 4. So, ito answer natin. At ito ay pareha lang. So, we have here another example. Lord Riley used the equation x double dot minus a minus b of x squared times x dot plus omega naught squared x equals 0. In his own discussion of nonlinear effects in acoustic phenomena, shows that differentiating this equation with respect to time and making the substitution y equals y sub o square root of 3b over x ax dot result in van der Waals equation y double dot equals a y sub o squared times y sub o squared minus y squared times y dot plus omega naught squared equals 0. So by using this equation daw, and this substitution, so ang result ay makukuha natin yung van der Waals equation na ito. So we have the solution. So differentiation of Rayleigh's equations and above yields. So we have x triple dot minus a minus 3b x squared times x double dot plus omega naught squared times x dot equals 0. So the substitution, so we're using the, so gagamit tayo ng substitution ngayon. Y equals y sub o square root of 3b over a x dot. So it implies that x dot equals square root of a over 3b times y over y sub o x double dot equals square root of a over 3b y dot over y sub o x triple dot equals square root of a over b y double dot over y sub o. When these expressions are substituted, we find square root of a over b, square root of a over 3b y double dot over y sub o equals square root of a over 3b times a minus 3b a over b y squared over y sub o squared times y dot over y sub o plus omega naught squared square root of a over 3b y over y naught ay y over y sub o equals 0. So in this equation we will multiply by y sub o 3 square root of 3b over a, and rearranging we arrive at van der Waals equation. So kagaya ng sinabi dito sa taas kanina na ito yung ma-result na makukuha natin na Van der equation, yung y double dot minus a over y sub o squared times y sub o squared minus y squared times y dot plus omega naught squared equals 0. So, ito yung result natin. Y double dot minus a over y sub o squared times y sub o squared minus y squared times y dot plus omega naught squared minus I equals omega naught squared y equals 0. So, ito yung nakuha natin dito ay